This conference will now be recorded.
In the previous session, as part of neural network, we discussed about feed-forward propagation. It is also known as multi-layer propagation. Quick recap of what we discussed as part of neural network. Sorry, as part of the first session of the neural network. So we have input layer, output layer. In between input and output layer, we have the hidden layer. So the input layer, this refers to each input features in the data set. The number of neurons in the input layer should be equal to the equivalent to the features in the data set. The next layer after the input layer is the hidden layer, right? So the hidden layer takes the input layer and applies the activation functions to it. The output layer is the predicted feature, right? And depends on the type of model you are building. So, and also we discussed about the activation functions, different activation functions we discussed. For different use cases, we use different activation functions. Now we can, as we can see in the feed-forward neural network, in this case, right, the error is 0.29837. Now, let us explore how we can reduce this error or the loss further. This is where the backpropagation comes into picture. Okay, the whole objective of backpropagation is to reduce the or minimize the loss. Okay, so in the case of backpropagation, the backpropagation uses gradient descent algorithm to minimize the loss. What is backpropagation? As part of this backpropagation step, right, the error is, see, in this case, the error is this one. See, we have two neurons in the output layer, right? So this is the error for this neuron 1 output. The output neuron 1 is propagated back within the whole network, one layer at a time. Incrementally, the objective is incrementally adjust these weights, right? These weights in order for the neural network to produce values that are as close as possible to the actual and predicted value. This is the actual value and predicted value. That is the whole objective of the backpropagation algorithm. So this process, let's we have taken one observation and then we pass the data from input to output layer, and then once we get the error, we backpropagate the error from the output layer to the immediate preceding layer until the input layer. Okay, so the idea here is we keep changing these weights. By keep changing the weights, we'll try to find out the minima, right? We keep changing these weights by finding the minimal cost. That's the whole objective of this one. See, the goal is to obtain the weights that minimize the losses. We need to obtain the weight by keep changing these weights, right? By keep changing these, we'll try to find out the loss for each set of weights. What is the loss? Right? The whole objective is, with which weights, with which value of the weights, we are able to minimize the loss. That's the whole objective of implementing backpropagation. So in order to obtain this weights which minimize the loss, we need to know the derivative of the slope. And the next step is the new weight has to be updated for all the weights in all the layers. Right, so that's what we are supposed to do it. And net, once we have the derivative of the loss function with respect to the weights, we can adjust the weights accordingly. We need to know the gradient of the slope. Why do we need to know the gradient of the slope? The gradient, this is the gradient of the slope tells us the direction we need to move towards the minima. This is what my minima. right? We need to direction. We need to know the direction. If we have the derivative, we can simply update the weights and biases by increasing or decreasing with it. This is known as gradient descent. One second. So this is what the objective of this one, right? So the end objective is we need to find out the weights that minimize the loss, right? For that we need to know the direction. Only when we know the slope, then we should be able to achieve the minimum, or we should be able to minimize the error. The value of the loss function tells us the goodness of a particular set of weights. That's the whole objective of the loss function. So once we have the derivative of the loss function with respect to the weights, we can adjust the weights accordingly. If we have the derivative, we can simply update the weights and biases by increasing and decreasing, reducing with it. That's what we have seen it, discussed it a while back. And this is known as gradient descent. However, we cannot directly calculate the derivative of the loss function with respect to the weights and biases, because the equation of the loss function does not contain the weights and biases. We need the chain rule to help us to calculate it. When it comes to the library like Keras, right, it takes care of gradient descent for us without requiring us to work out the chain rule from scratch. So okay, let's dive into the inner workings of how the weights are updated with a working example in the next video.